A lecturer at Stanford University, and Jesse will be speaking about using lichens as indicators of forest stand age and conservation value. And I'll turn it over to Jesse. Thank you.
Thank you very much. Can you all see my slides and hear me? Just have to check. It's a little ritual, a year plus into the Zoom era. Anyway, it's fantastic to be here. It's been so much fun hearing all the talks so far. I want to say thanks to the organizers. I'm super impressed by this conference. This has been really great. And yeah, including the artists was a really nice touch. Anyway, I'm just so pleased with how this has turned out and really happy I get to talk about my research too. So today I'm going to talk about a project that I did over the last few years in collaboration with some familiar faces, John Villela, Daphne Stone, and Amanda Hardman. And the big picture question that we're interested in is how can we recognize habitats that have high conservation value? And this is a question that's critically important for conservation planning. Most of us recognize an old growth forest as a habitat of high conservation value when we walk into one of these forests, but it's difficult to actually quantify conservation value or to compare different sites and assess what their relative conservation values are and which ones perhaps should be prioritized for conservation or restoration and other kinds of management. But in general, we might be able to assume that sites that have experienced less degradation because of anthropogenic activities might have higher conservation value. Not to say all anthropogenic activities reduce conservation value. We know that's not the case. We also know that in general, sites with older trees or older plants in general, I'm thinking big here and including old growth grasslands, for example, might have higher conservation value, all else being equal. So of course, where this is going is how can we use lichens to help us understand and assess habitat conservation value. But it's going to take me a minute to get to the lichens, because first I want to talk about plants as kind of an example and a case study that inspired the study we did with lichens. So it's pretty well established that lichens have predictable successional affinities. So did I say lichens? I meant plants. Plants have predictable successional affinities. So there are certain plants that have affinities for more disturbed habitats. Certain plants have affinities for less disturbed late successional habitats. And this has actually been quantified in a system that's now really widely used. It's called the coefficient of conservatism. And I'll give you an example of how this works using the coefficient of conservatism rankings from British Columbia. And so the way this works is all plant species in a region are ranked on a scale of 1 to 10. Species that are generalists or adventive species that are well suited to disturbed conditions receive low rankings in the range of 1 to 3. Species that don't necessarily tolerate intense disturbance, but also don't necessarily need really pristine, undisturbed conditions are ranked with intermediate numbers. And species that we might consider late successional specialists receive higher rankings in the range of 7 to 10. And I have to admit, when I first heard of this plant coefficient of conservatism system, I was very skeptical. I thought this was like the least scientific thing I'd ever heard of. For one thing, these rankings are determined by experts. So a bunch of experienced botanists in a region will get together and make these rankings or determine these rankings. And I thought, well, that's totally subjective. It doesn't seem like this would be useful at all, right? But nonetheless, it turns out these coefficient of conservatism systems are super widely used, especially in the Eastern US, where there are fewer high quality native habitat remnants compared to what we have out west. And ecologists have debated whether these coefficient of conservatism rankings are actually biologically meaningful. And personally, I became convinced that these are actually useful once I started to look at the evidence that there is assessing their validity and utility. And one example of this is, and there are several studies of this nature, but one study found that species with similar coefficient of conservatism values are more likely to co-occur, suggesting that there really is some kind of biological meaning to these values. And then more recently, there have also been a handful of studies looking at relationships between plant functional traits and coefficient of conservatism values. So for example, one study found that species that grow more slowly tend to have higher coefficient of conservatism scores, which is of course exactly what we'd expect for species with affinities for relatively undisturbed late successional habitats, as opposed to adventive early successional species. So the question I'm getting to here is, can we use lichens in a similar way as indicators of late successional habitats and perhaps more broadly habitats with high conservation value? And one clue that this may be possible is we already use lichens as indicators of other related things. And of course, the best known example of this is systems that rank lichens according to their affinity for air quality. We have some lichens that are highly sensitive to air pollution. We have other lichens that actually do quite well in places with nitrogen enrichment, as we've heard about in earlier talks, so I won't go into that in detail. So could we come up with a similar system to use lichens to inform us about late successional habitats and habitat conservation value? And one clue suggesting this is possible is we know that there are a number of lichen species that have strong affinities for old growth forests. Nephroma occultum is one great example, Pseudocephalaria rainirensis. These are both species that pretty much only occur in old growth forests. And then we have species like Loberia oregana, which aren't strictly or completely restricted to old growth forests, but still have a strong affinity with old growth forests. They're likely to be found there. And then at the other end of the spectrum, we also have lichens like Xanthorias and Physias that are associated with early successional habitats. They might be the earliest colonizers on a substrate, like on a young tree branch. I know I see that on young tree branches here in California a lot. And then we have a lot of lichens that, are kind of intermediate, just like we talked about with the plants. They don't necessarily occur in highly disturbed environments, but they don't necessarily need an old growth type environment either to survive. So a couple examples from California that might fit in this group include Ramelinum menziesii, our state lichen, and Hypogymnia, the tube lichens. And a number of lichenologists over the years have developed lists of old growth indicator lichens. Typically, these lists just assign lichens as either old growth indicators or not. So it's basically a binary system. One limitation of this research is that these old growth indicator lists have rarely been tested quantitatively. And when they are tested using real world data, they've usually just been tested at really narrow geographic scales, so not across broad regional scales. So we don't really know if they are meaningful across broad areas. The binary system may represent a limitation, because we would expect that all species in the community should be giving us information about the conditions where they're growing. But trying to fit all the species into just two categories of either being old growth indicators or not may not be, there may be more information they're telling us than just trying to fit it into a binary framework. So with that as our inspiration, we developed what we called a lichen conservation index, where we ranked all common Pacific Northwest epiphytic macrolichens using Bruce's macrolichens book as the species list. And we ranked them on a scale of 1 to 10, just like the plant conservation index I talked about. And we used what we might call a wisdom of the crowd approach, similar to how plant rankings have been assigned. So we all ranked these species independently without consulting with one another, and then developed final rankings through consensus. And so the species were ranked on a scale of 1 to 10, where species with low values are early successional species or adventive species. And then the species ranked with high numbers are species that we thought were associated with late successional habitats and old growth forests. And I should note that my collaborators who assigned these rankings are all really experienced lichenologists. They're some of the most experienced field lichenologists in the Pacific Northwest. So we were basically interested in seeing whether our field experience, whether, what we've learned through all the years of field work is really meaningful when we try to actually evaluate it using real data. And so to evaluate these rankings, we used FIA data, which several people have talked about in previous talks, but these are plots that are sampled for lichens using a standard protocol. And so we used plots in the Cascades of Oregon and Southern Washington to test whether there was actually a relationship between forest stand age and the rankings that we gave the lichens. Because if the rankings are actually biological meaningful, we should see more species with higher rankings in late successional forests or old growth forests. And so I'll show you our results. And these are published in a paper that came out a few months ago in Forest Ecology and Management. So on the x-axis of this figure, we have stand age, so the age of a forest stand in years. And then on the y-axis, we have the conservation index. So each of these boxes represents the range of stand ages where lichens that were given this ranking occurred. So you can see that lichens that were given a ranking of 2 tended to occur in stands that were roughly 50 to 75 years old. Species with intermediate rankings tended to occur in stands that were between 100 and 150 years old. And species that we ranked 10, which was the highest number, tended to occur in stands that were over 200 years old. So there did seem to be an actual relationship between forest stand age and these rankings, even though we assigned the rankings, just based on our field experience. And then for the next step in this analysis, we averaged the rankings of all these species that occurred in each of the FIA plots to calculate a site average. So this is just a made up example with a few species I pulled off the species list. So for the given species that occurred in a plot, we just took each of their rankings and averaged them. And then we looked at the relationship between the plot level average and stand age. And so this is what we found. We have stand age on the x-axis here and the average plot level conservation index value on the y-axis. And so you can see there is a pretty nice positive relationship between forest stand age and the average lichen conservation index value. And then just for the sake of comparison, because so many people have used binary indices in the past where species are just assigned as old growth indicators or not, we also use the exact same data set and just assign the species as either old growth indicators or not using a binary approach. And we found that there was still a positive relationship between stand age and the number of old growth indicator species, but it was a weaker relationship than the continuous index. So it suggests that the continuous index does actually give us more information about what's going on, which is not really surprising, of course. So is this actually useful in the real world? The whole reason we did this project is because we think the answer is yes. We think that this could be applied to some real world conservation issues. And the first example that comes to mind is in the Pacific Northwest on federal lands. Pre-disturbance surveys for lichens are commonly conducted. So land managers have all these species lists of lichens that occur in timber units. And this is the work that I did for many years and that all my collaborators have done. Land managers end up with all these species lists for all these timber units, but land managers often have no training at all in lichenology and don't really know what to do with these species lists. If rare lichens, if listed lichens are encountered, then the managers may account for those in their management plans, but they're not really able to interpret the species list very much. So
1 minute left, Jesse.
Okay, thanks. Using these rankings could allow managers to compare different timber units and identify sites with particularly high conservation value. And this ranking system could also allow us to assess the outcomes of restoration treatments or other management practices. For example, we know that thinning dense timber plantations can actually lead to increases in cyanolichen richness. So this system could provide a quantitative way to evaluate that. These are photos from a study Heather Root did looking at thinning effects on lichens. And potentially, this kind of idea could be expanded to other ecosystems. Like we know certain old growth grassland soil crust lichens are associated with high quality, relatively undisturbed sagebrush steppe ecosystems. Another example close to where I live in San Francisco, and we have these really sweet communities of cyanolichens in old growth maritime chaparral on coastal peaks, which may not be on the radar of land managers, but a system like this could help them identify these sites of particularly high conservation value, at least from the perspective of lichen communities. So in conclusion, we all know we're living in an era where we face major challenges, habitat loss and degradation, but I'm hopeful that using lichens as indicators can be at least one little step towards helping address these challenges. So finally, I encourage everyone to try out these rankings. If you have a lichen community data set you're working with, let us know what you think. I'll put the link to the ranking spreadsheet in the chat. You can also get them on my website. The paper is also on there. And finally, we do plan to eventually produce a revised list of the rankings once people have tested it more. So if you have suggestions for improving the rankings, I'd like to hear them. And here's my contact info, and I would be happy to take questions. Thanks.
Thank you for that, Jesse. That was great. And we have quite a few questions. Okay, so from Shanna, is anything like this being done in New England that you know of?
As we think that this is the first time someone has done a continuous old growth ranking system like this for lichens. So yeah, as far as we know, no, but if anyone knows something different, we'd like to hear about it. But this could, obviously this could be replicated anywhere. And it's not that hard to do. You just have to poll a few experienced lichenologists and ask them to come up with rankings.
Yeah. From Bruce, can you use the observed relationships with stand age to refine your original species by species rating?
Yeah.
Which would in turn create a stronger relationship to stand age.
Yeah, that's a great question. And yeah, we absolutely could. There's no perfect empirical data set. So we're a little hesitant to just use the FIA data set, to completely assign them. But it would certainly be possible. And if we had complete faith that the FIA data set was perfect, we certainly could. Working with it a little bit, I guess I'd be a little hesitant to completely rely on it. But yeah, that would be an interesting conversation to discuss more. I think there's no question that our list could certainly be refined and improved more. And we've already identified a few species in it where we would change the rankings after, thinking about it a little bit more.